So here's some more transmitter tests. For those who don't know what's going on, this is a miniature magnifying solid-state Teslacoil, and it's built to the correct proportions for possible energy synthesis from the environment, meaning when it's activated, we're using a small amount of energy to move a larger amount of energy, and we should, in theory, be able to create unlimited lighting and power up an unlimited amount of electrical loads as long as we're separately earth grounded and in range of the transmitter. So as you see, this is just a ball, stainless steel ball. There's nothing in the transmitter. There's nothing underneath the transmitter. It sits in a glass plate with a little bit of water, and I had a little bit of water in there to keep the heatsink cool because I'm testing it and pushing it at really high power levels. It's a simple Slayer exciter circuit, but it's on a very well tuned coil, and this is just a resonant capacitor on the L1. The L1 is 8 gauge and it's 1 inch long. The whole thing is constructed on 2-inch diameter PVC pipe, and a perfect Teslacoil is just as wide as it is tall. The length of the coil would be your voltage and the diameter would be your amperage, and if you get those two in balance, you have equal voltage and equal amperage. But the coil also can't be too big or too small. So I don't want to say it's perfect, but some pretty good dimensions I found from reading a lot of Don Smith work, Eric Dollard, and old electrical engineering textbooks was, if you have a coil, so you make your L1 1 inch long on 2-inch diameter PVC pipe, and your L2, which is cut under dielectric tape here, transformer tape, is 4 inches long, and your extra coil, which is wound counterclockwise, is 2 inches long, and your dielectric antenna should never be more than half the size of your coil, otherwise it will overload the system. So we have the L1, the L2, which you can't see, it's protected under the transformer tape, the dielectric tape. We have the L3 coil, which is wound counterclockwise. We have the L4, which is the ball, the dielectric antenna. So this is wound clockwise, L1 is clockwise, L2 is clockwise, L3 is counterclockwise, and the ball just sits up on there. I just twisted it on there. I leave it there so I can remove it for convenience. Try different balls that I got hanging around, and that sounded kind of funny. This is what the transmitter looks like. This one, I retired this one. This was the Mark II version, the older version. Basically what I got going on here is, this is my earth grounded wire. You see that just connects to my outlet up there, earth ground. When I run the transmitter, it runs off of a DC powered supply that's plugged into a watt meter, so I can see exactly how many watts I'm using, the transmitter is using. Because when I run wireless electrical loads, they don't put a drain on the transmitter at all. When you separately ground a wireless electrical load, it doesn't put a drain on the transmitter whatsoever. So I noticed if you're within the near field of the transmitter, it puts a drain on it, but if you're in the far field of the transmitter, there is no electrical drain. That's my DC supply. It goes from 0 volts up to 60, I think, 5 amp. So anyway, I'll take the ground wire again, and I noticed just having this receiver coil, which is built exactly identical to this one, minus the ball, it actually doesn't work as good when I put the ball on here, which is interesting. So I'll turn this on, and immediately turning it on, we have wireless power ignition. As you can see, there's just a chain of lights I made that light up with special diodes. So this is the radiant energy effect. I can touch this to anything metal, and this thing will light up ridiculously bright. Like, that's unheard of. This thing is not your average lossy spark gap Teslacoil that doesn't know what it's doing. A real Teslacoil is a generator of energy that harvests more power than it needs to run it from the environment. So anyway, I'll take my grounded wire here, and look at the amount of power that comes out of just a receiver. This is a wireless receiver. And this is just a wireless receiver that's in range of the transmitter. Like, look at that. That's some real power. And the leads heat up in my hands. And I can take a bulb and do this. Like, look at that. If that's not impressive, I don't know what is. But anyway, the interesting thing I discovered is when earth grounding a receiver coil, just like that, the receiver coil is now earth grounded. We are not impacting the transmitter in any way, and we have much more impressive wireless power. The range has become incredible, and I can touch it to anything metal, and the light gets blindingly bright. I don't think anyone has discovered that effect before. So, I can also touch it to anything metal that's grounded. It's extremely bright. I can walk anywhere in my room or my house, and it gets extremely bright. I can even walk into another room or my bathroom, and it will light. Grounded outlet. Look at that. Very bright. Grounded bathroom sink. Very bright. Heater. Very bright. The stove. Very bright. Might be a world record, I'm not sure. Heater. Just loves the ground. It's glowing just being near the earth ground. That's bright. This heater, it's glowing just being near it. It's also important to know it's a very wet, snowy day out, very good ground, and it seems to love that. I can hold it. There we go. My sink in here. Very bright. Up here. Very bright. Random metal objects have a charge. Just bringing them near the metal objects. My lamp. So, and this range worked all the way to my shed over there. And I don't feel like walking all the way out there in the snow to show that. This room, even anything metal, this is a guitar. Very bright, because it's isolated. It's acting as an antenna. Just a screw in the wall. And all that, those massive range increases occurred from earth grounding the receiver here, this wireless receiver, which I can literally disconnect, pick up, and walk away with. Like, there's nothing hidden in it. I wouldn't waste years of my research to faking things. So, anyway, I can also take fluorescent tube. Here's how good I got the wireless range up to with the thing. And keep in mind, I can get a much beefier transistor for that circuit. And I can run that off of much higher DC voltage with lower current. And the radiant energy effect should become extreme. And I can't get too close to this or my phone will shut off. So anyway, I'm demonstrating that, the extreme range. And I also have these lights up here lit wirelessly from the device. They just hang with one wire. That one's kind of free hanging. This part of it just terminates into earth ground. You can see right up in there. Something the lights can work against. But anyway, I'll put this tube back down. And I'll demonstrate that this will light up again. Literally, I can just hold this to the metal rail in my closet and it lights extremely bright. And these receiver lights are made with 1N4148 diodes. And it's just a jumbo 10mm LED. And how cool is this? I collect rocks that give off energy, like for a crystal radio. And I can touch this to the bucket of water, and I don't get zapped. Figure that out. And I'll shut the system off. System is off. All radiant energy effects have ceased. That is not lit. That is not lit. All these lights are out. I didn't even show you the interesting thing yet. So, because this right here is varying its capacitance with respect to time, because the system is pulsing, it's sucking in charge from the atmosphere. And how to increase this is this ball has to be coated with something clear. Well, first we would coat the ball in something that glows. And I don't know what that material is, and I'm not going to disclose that because that's one of my upcoming improvements to the device. Is the ball is going to be coated with a material that sucks in more charge from the air, more ions. And then after it's coated with that, it'll be coated in plastic. Because every radiant energy patent has a clear coating around it. It's just an insulated piece of metal with a clear coating, like this. This is a big block of metal with a lead that comes off the bottom. Big plate of metal I got for free from a machine shop. But anyway, I'll show the interesting effect. Scotty diodes. Has to be Scotty diodes for this application. Here is the over unity effect. This is a full bridge rectifier made from Scotty diodes. I will connect it to my L1. The AC side of the Scotty diode goes to the L1. So as you can see, our full bridge rectifier, which is made out of Scotty diodes, 80 volt Scotty diodes, 20 amperes, go to the L1. And I tried this with other Scotty diodes. They all melted and blew up. They'll be close to a 500 watt output here. So anyway, turn the system on. I'll connect a 150 watt halogen bulb. Hopefully you can see this. 150 watt halogen. And it will ignite to full intensity. And it will cost me a fraction of the power it would normally take to light this. So, bulb is connected. We have full brightness. It costs us, so load is now disconnected. Load is connected. So it would only cost us less than 300 milliamps to run a halogen to full intensity. So load disconnected. That's our power going into the transmitter. Halogen connected. I'm going to try and demonstrate the effect on the motor. So I have to be careful because this motor will take off like a rocket. Here we go. We have real electromotive force. And I can also run this big bulb, which will get extremely hot. This is a 200 watter. He comes up to a nice glow. Not full intensity. These are 200 watt or 300 watt. So that's the output here. All from a Scotty diode full bridge rectifier going to the L1 of the transmitter. And that collapsed field is what's running the load. So we'll do a current check. We'll see how much DC current we have. And this is DC because it's going through a rectifier. So the way we measure DC output current is we measure the amperage. So we have 3.5 amps here. And our voltage is 68, 70, about climbs, it fluctuates. We'll just say it's 65. And here's our amperage again. Now the interesting thing is I can get this amperage even higher by taking this ball, putting it here, removing the ground wire, connecting the ground wire to the ball. Now look at my amperage. 4.30 amps DC at 107 volts. So the way you do a power calculation for DC, you do voltage times current, which would be, we'll say it's 105 volts, times .5 amps. I gotta do the math on that. I have calculators for everything. I am horrible at mental math. It's probably like 200 or 300 watts. We now have the ability to run the halogen bulb significantly brighter if I can connect to it and everything stops fighting me. Halogen bulb is now full intensity, absolutely full intensity. We'll read how much voltage is left over in the bulb while it's being run. I'm just going to get leads and clip to that. Avoid all the issues of it fighting me. So we have a voltage left over of 120 volts DC while we're running a halogen bulb to full intensity. And we can also still create mind-bending wireless power. So that's going, and I still have the radiant energy effects. So I don't know of any other system in the world that can do that. Boop, radiant energy. Pretty cool shit, huh? Like that's, I don't think anyone else in the world has this, or if they do, it's kept hidden in the lab and classified. So we have 98 volts left over, running a halogen load to full intensity. I'll disconnect the halogen load. We drop to 1 amp power consumption on the transmitter. Connect the halogen load again. We go up to, what, like 350 milliamps to run that. There's a lot more than 350 milliamps there, folks. Like, that's hot. You could cook 1 egg on that. That's heat. So anyway, I'm going to disconnect this. And I'm going to run the bigger bulb. Should get the bigger bulb very bright. And you don't want to touch this. This will pop your fingers. We now have the bigger bulb being run. Much brighter. Feel heat coming from them already. So there's a lot more than 300 milliamps flowing through that bulb for current. We'll do a power reading again. The wattage calculation for DC is voltage times current, which is your wattage. And we know it's accurate. We have pure DC coming out of the fastest available Scotty diodes we can get. I'll have the number for those soon. So our voltage is 106 volts DC, 107. And it all that power gain came just from grounding that metal ball on the receiver side. So here's the amperage. We have 4 amps. Kind of weird it's dropping. Maybe I can tune it a bit. Tuning by moving this around. Okay, it's up to 4 amps again. I had it at 5 amps at one point. Okay. There's our output. You can tell it's there and it's real. And I feel heat in the wires. So 4 amps DC times 100 volts. That's our output in watts, which can run this 150 watt halogen to full intensity. Like, damn. And we still get wireless power. Extreme wireless power. So, whoops. Just drop that. Anyway. That's basically what I wanted to show. No other system I know of in the world can do that. I showed the extreme over unity output from the collapsing field of the L1. That's a lot of heat there. And again, we can just see the leads clearly. You can see the leads clearly. Comes off the transmitter. There's nothing under the table. Gonna shut it off and feel how hot things got. Nothing's really that hot. It's getting kind of warm though. Not that bad. And for those who want to know, the L2 is constructed with 26 gauge wire, pretty thick. Real Teslacoil is a high Q factor coil, not a very thin, skinny coil. So anyway, I'll turn this back on, and I'll show you how bright this gets when I hook up to it. This is just your typical LED light. So not only can we run halogens at a fraction of the cost of what it would regularly cost us to run. If I can connect to the fucking thing. There we go. It's extremely bright. I think you guys get the point. Holy shit, that's bright. We still got wireless power. Extremely efficient wireless power. So, you guys can see that. Good lord, that's bright and hot. I'll shut that off. And again, if you do this, you gotta watch out for heat. These diodes will get very hot. They'll have a close to a 500 watt output. No joke. So, I'll just show you guys how it looks. Disconnect it. Come on. Everything fights you when you do a video one-handed. So, here's a transmitter. There's absolutely nothing underneath it. There's nothing inside it. It's just the ball. And these tests would not work nearly as good without the ball for the transmitter side or the grounded ball on the receiving side. And for that test where it gave the huge output power from the rectifier to the L1, we didn't need this extra coil here. I just put the ball here because it's the perfect height, and that's why it works so well. So that's all I wanted to show. And I'll show the measurements if I have my measuring tape around, which I don't. Oh well. But anyway, you can see it. The coil's kind of a work of art. You have to construct it to look neat, and you can do remarkable things with it. So again, 8 gauge wire, 4 turns, L2, 26 gauge, 4 inches long. I don't count the turns, I just go by the length, which is all you really need. And the L3, 2 inches long, 18 gauge. And just a ball, 8-inch diameter, can be any metal ball. So again, L1, 1-inch long, L2, 4-inch long, L3, 2-inch long, counterclockwise wound, and just the ball. You can kind of see that here, because this coil is constructed exactly the same as this one, except this wire gauge is much thicker. The L2 is much thicker. So, you can see how that comes up. L2 connects in series to L3, and you can see how L3 is wound in the opposite direction of L2. And that's all basically I wanted to show. That's the transistor that runs it. And thank you for all those who support me.